Yeah, so good morning. Welcome to this section. So, in this particular section, we have a question which means that we should make any subject in a relation H is equal to MT all over D into brackets N plus P. So, we begin slowly and then go through the processes carefully. So, because we want to make M the subjects, we know H is the same as H over 1. Then this is equal to MT over D into brackets N plus P. So we can now cross multiply so that we have two separate terms. So by cross multiplication, I can get mt times 1 is equal to h into bracket d into bracket m plus d. So because I want to make the subject, I have to expand this side so that I can have my chain. So by so doing, mt times 1 is going to be mt is equal to h times, so d times and down h into bracket dn plus dp. Okay, then from here we can have mt is equal to d times h and dm times h will be also dmh and plus dhp. Okay, I want to make m the summation. So let's move m to this side, given as mt minus d and h is equal to nhp. Then from here, because we want to make m the subject, we have to factorize m out. Since m is here, m is here. When I take m out, I'll be having 2 left here. Then over here, I'm having h, which is equal to dhp. So because I want to make m the subject, I divide through by 2 minus dh, 2 minus dh. So I have my m now, dhp over 2 minus dh. So therefore, m is equal to dhp over 2 minus dh. So basically, this is the value we get when m the subject. Alright, so we continue with the second question, which says that given the relation t is equal to square root of v 1 over n plus 1 over 10, make J the subject of the relation, and then find G when t is equal to 3, f is equal to 12, and then f is also equal to 5. So in this case, we try and make J the subject. So we begin t is now equal to root of root all over 1 over f plus 1 over 10. So because we want to make J the subject and J the subject and square root, we have to square both sides so that we can have the square root taken away. So we have t squared here is equal to, over here we are going to have root of v all over 1 f plus 1 over 10 all squares. So this is with this. Then we have t squared now being equal to u over 1 over n plus 1 over 10. So continue quickly from the top here. So from here you can now cross multiply, and then when you do the cross multiplication, or before you can even do the cross multiplication, let's try and simplify this fraction with the down. So t squared is equal to u over 1 f plus 1 over 10. Then else we are on the right hand side is going to be f to change. So it's u over, then we have fg. F goes into everything, j times, so j times s is here be f. So we have t squared now given us u over g plus f all over f g. We know this is over 1, so from cross multiplication we get u is equal to t squared times j plus f all over j f. or f gene. Okay, so from here, yeah, so from here we can further do multiplication, and by multiplication we can have this as u is equal to t squared into bracket j plus f all over gf. Then we can cross multiply again. This will give us gf giving us t squared j plus f like this. Then from here, because we want to make g a subject, we expand the side. So we have gf giving us t squared j plus t squared f. Want to make g a subject, let's move this to this side and this to the other side. Okay, so we have f g u minus t squared j is equal to t squared f. J out, what is left? F u minus t squared is equal to t squared f. J now becomes t squared f all over j into bracket. Sorry, all over f u, my bad, actually, minus t squared. So j is equal to t squared f all over f u minus t squared. Okay, now we have to find the value of j when t is equal to 3, f is equal to 4, and then u is equal to 5. So substitution, j now becomes 3 squared 4 over 4 to bracket 5 minus 3 squared. Okay, so u is 4, and then f is f is 4, u is 5, and then t is 3. Okay, so j is equal to 9 4 over 20 minus 9, which is equal to 36 over 11. So you can leave our answer like this: we better still 3 whole number, that will then times 3, 33, and maybe 3 over 11. So we have this as the answer for these two questions. Alright, so this is the question 3 over here, which says that given a 2 3 b minus 2 1 and then c 2 3 and where x is a constant, we have to find the magnitude of AB. Then we know magnitude of AB is given by the formula square root of x squared square root of x1 or x2 minus x1 all squared plus y2 minus y1 all squared. So we take A, then we take B, we consider them. So we can assume that our x2 should be minus 2. If x is minus 2, then we can have square root of minus 2 minus 1 all squared plus minus 1 minus 3 all squared. So if that is the case, now we can have this situation. This is going to be minus 3 all squared plus minus 4 all squared. Then we know my negative number in the bracket square should give us a positive number. So we have 9 plus 16, which is equal to the square root of 25. And then because we are interested in the magnitude, to break this down to the simplest form, which is going to be 5 units. We're not given a specific unit of measure, so we just say 5 units. And the second question also demands that we find the value of if BC is equal to 4 minus 5. So we know BC the ABC the same as OC minus OB. Then we have OC which is the same as C, OB the same as C. So this is going to be 2 3m minus 2 minus 1, which will be giving us 2 minus 2 3m minus 1. Then this is going to be 2 plus 2 3m plus 1. Then we are told that if this is the same as 4 minus 5, then you have to find the value of m. So you say this is equal to 4 3m plus 1. So you can see the 4 reflecting here. So we can equate them now. So 4 3m plus 1. Okay. So by doing so, we can compare 3m plus 1 to negative 5. 3m is equal to negative 5 minus 1. 3m is equal to negative 6. M is equal to negative 6 over 3. M is equal to negative 2. So therefore, M is equal to negative 2. Alright, so we quickly continue with question 4. It says that the functions f and g are defined as follows. F of x maps into x minus 1 all over 2 and g of x maps into 3x plus 1. We are to evaluate f of negative half plus 1. And then also we have to solve f of x is equal to g of negative 2. So we begin with the first one. We know f of x is given by x minus 1 all over 2. And then using x to find f of negative 1 over 2 plus 1. Meaning that in place of x we put negative 1 over 2. So we have negative 1 over 2 minus 1 all over 2 all plus 1 like this. Now we simplify the numerator of the fraction. The LCM there is going to be 2. We're going to have negative 1 minus, this is over 1. 1 goes into 2 times. So 2 times this will be negative 2 all over 2 like this, and then all plus 1 like this. So we continue. This is going to be minus 3 over 2 all over 2 plus 1. We know minus 3 over 2 is going to be divided by 2 all of this plus 1. Then this can further be written as negative 3 over 2 times 1 over 2 plus 1 like this. Then we know this side is going to be negative 3 over 4 plus 1. We find the LCM 4. 4 goes here 1, negative 3. 1 goes here 4, so 4. We get 1 over 4 as the answer to the first question. Yeah, so we get 1 over 4 as the answer to the first question. And then the second question too says that we should find the value of x, that is f of x is equal to g of negative 2. In place of this x here, I put negative 2. In place of the x here, I put negative 2. That is what is going to guide me. So I know f of x is x minus 1 over 2. And then g of x is going to bracket minus 2 plus 1. Then this will give us x minus 1 over 2 minus 6 plus 1. X minus 1 over 2 is equal to minus 5. Cross multiplication, I get x minus 1 is equal to minus 10. X is equal to negative 10 plus 1. X is equal to negative 9. So question 1, question 2, question 3, question 4 have been answered. I'm hoping to bring you further questions in the coming days. Thank you for listening. Then don't forget that this is Happy Class.